This lecture will be a continuation of our lecture in functions. And the first lecture, I've already defined a function graphically, numerically, and algebraically. Now I'm going to discuss to you how to make or how to describe a certain function in terms of words. We're going to show it using graphs and using some numbers and letters also, of course. So the picture or the image that you see here is just the graph of the previous lecture as you have seen it. So this just shows you the relationship between the coffee temperature, and the time of passing. So as you can see, this is our domain here. Actually, our domain in the table goes from 10 to 20 only, but in here it's extended. So this is the domain, and this is the range. So our range, remember, is from 0 to 20, but will not be equal to 20 because of this asymptote here, or the limit of your range, wherein your graph will try to approach this one, the one with arrow here, will try to approach it but will not be equal to it because of certain factors. Now in this case, it's because of thermal conductivity of the coffee, temperature, and the room temperature. At some point, they won't be equal to each other. They won't reach an equilibrium. And that's for your homework to do, as I've said. So I hope that clarified everything. Okay, now we move on to the next topic. So functions as defined verbally. Okay, verbally, if you are given a certain problem, like in this case, we are given an example, and this example is in words. So let us read. The time it takes you to get home from a football game is related. So the time it takes you to get home from a football game is related to how fast you drive. Sketch a reasonable graph showing how this time and speed are related. Tell the domain and range of the function. Okay, first we are going to, of course, describe the relationship between time and speed at certain points. Now, the first thing that we're going to do is to label the Cartesian coordinate axis here. So let's label this as x-axis, and this one is y-axis. This y-axis here will be your time. It doesn't matter what kind of unit you're going to use. You can use seconds, you can use minutes, you can use hours. But practically, of course, seeing the speed, it's a car. So most practically, we are going to use hours. And in this point, the one below our x-axis would be for the speed. It would be for speed. Okay, what's happening to my pen? It would be for speed. So this speed would be, if you choose hours there in time, this would be let's say kilometer per hour or meter per hour. Let's use kilometer per hour. Okay, so you can see that there are horizontal lines and vertical lines drawn all over. Now the reason why I put those horizontal lines and vertical lines is to present to you a relationship that goes between time and speed at certain points. Now in this case, you notice that the speed is slower, right? This speed is slower. Your car runs slow. You are driving slowly. Those are the key sentences. Now when you drive slowly, of course, it would take you longer to where you want to go. That's why your T is kind of what do you call this? It's high. This is your T and this is your my T doesn't look like T. So this is your T and this is your time. Let's say S. Okay, when you drive slowly, you go somewhere longer. Am I correct? Okay, now let's see the other the other pair of vertical and horizontal line here. Now as you can see here, you are driving a little bit faster. Okay, now the time that you take to go to a certain place is let's call it T2. Okay, this is S1, this is S2. Now we have defined a point somewhere here. Okay, that's when you are not driving too slow or too fast, so you would go home to a certain time T2, which is just okay. Maybe you won't be late or you won't be too early. Now you can also see another pair of horizontal and vertical line here. Now in this point, okay, you are driving too fast. So you are driving too fast. So that's, let's say, S3. Of course, if you are driving too fast, you are going to get somewhere to a certain T3 very fast. Am I correct? So these are the points that describe how you drive and how fast you get home. It takes you to get home from a football game. Okay, so let us look at the curvature or the graph of this function. Okay, I'm going to draw. Okay, that's not very good. Let's use some. That's not very good also. Okay, let's use something. Okay. Oops, this is approximately better. Okay. Okay. It shouldn't touch. Okay, in this example, notice the movement or the direction of the arrows going to the x-axis and to the y-axis. As you notice, your S or your speed approaches 0 and your time S, which is also equal to your x, and your time, which is equal to y, approaches 0. How? As you can see, this arrow here tries to approach 0 or the x-axis, or in this case this is also equal to y is equal to 0, and in this case y-axis, this is also equal to x is equal to 0. Note, this is your x is equal to 1. I'm going to show you why. This is certain point. This one is equal to x1, which is equal to s1. Okay, and so on and so forth. This is x2, is equal to S2. This is x3 is equal to S3. So as you can see, this one is also equal to y1. This is equal to y2. This is equal to y3. This one equal to y3. And of course, this part here is equal to y is equal to 0, and this part here is equal to x is equal to 0. Now, as you can see, the graph is approaching x is equal to 0. It approaches 0, but it's not going to be equal to 0. And this one will be approaching y is equal to 0, but will not be equal. It's approaching but will not be equal to y is equal to 0. Now, why is that so? Now, remember, practically, if you are going to drive at a speed of 0, your car would move, right? That's why it wouldn't be your speed S2 or X2, X or S won't be equal to 0. And the time that you go home won't be equal to 0, no matter how slow you drive. So let's get the domain now. Our domain would be from X, this is our domain. It would be, what is our X? It would be greater than 0, and it would be less than or equal to the maximum speed limit. It won't override your maximum speed limit, because if you override the maximum speed limit, then your car would be broken. Is it correct? You are going to destroy your engine and everything. Okay, next, what is our range? Our range here is y, so our range would be equal to y approaching 0, so it's greater than 0, of course, and it's dependent on the time of where your maximum speed is. It depends on the maximum speed of your car. So at the maximum speed of let's say 160 kilometers per hour, you would have a certain time, which is the least time. So this just tries to go that your function for the speed of the car and the time it takes you to get home is inverse relationship. By inverse relationship means that when one of your, okay, let me explain this in terms of a certain relationship. So it's like 1 over x. Okay, if your y goes up, what would happen to your, or inversely, if your x goes up, your y will go down. Okay, technically your y would go down as x goes up. Now your y would go up if your x goes down. That's what an inverse relationship is, and this is described by your graph here, the one that you can see here. So this would be the discussion for part 2, which is describing a function verbally. And I hope you gained a lot of information and you are clarified for your questions. And again, thank you for watching and listening.